Okay, now we're on to page 2 here. We have a new challenge. Our challenge now is to work on some angles that are all on the exterior of the circle. There are 3 different scenarios, so let's take a look. It says if secants and or tangents intersect on the exterior of a circle, then the measures of the angle formed is equal to half the difference of the intercepted arcs. Difference means subtraction. Okay, so for our first page, the formula said that the angle was equal to half the sum. For this portion of our notes, our angle is going to be equal to half of the difference of the 2 arcs. Okay, so let's take a look at the 3 possibilities. Here's if we had 2 secants. Okay, if we have 2 secants, the 2 intercepted arcs are BD and CE. So the angle is equal to 1/2 the 2 arcs. Now, if we want to come up with a positive number, we want to do big arc subtract little arc. If we did little arc subtract big arc, we would come up with a negative number. So this would be the measure of arc CE subtract the measure of arc BD. Okay. When we're looking at a secant and a tangent, let's find the 2 intercepted arcs. We've got BC and B all the way around to D. So the only portion of the circle not being used is outside of the angle. The angle is equal to 1/2 the difference of the 2 arcs. Remember, you want to start with your big arc to keep your answer positive. So BD is the big arc, BC is the small arc. Finally, what happens if you have 2 tangents? Well, you still have to find the 2 intercepted arcs. This time, the 2 intercepted arcs wind up being the entire circle. Okay. It splits right there at point B and point C. So if I'm following this pattern, the angle is equal to 1/2 the difference of the 2 arcs. Large arc first, which in this case is the major arc BDC, minus the minor arc, just B to C. So the 3 situations are all using the same formula, but they do look slightly different, so I thought I'd show you that. Let's do a few examples. We're trying to solve for angle KLM here. This is 2 intersecting secants, so most looks like our very first piece of the notes here. We need to identify the 2 intercepted arcs. That would be from K to M and all the way out from J to N. Our formula says that the angle is equal to half the difference of the 2 arcs. So our angle is what we're looking for. We're looking for the angle. I'll put an X in the angle position. That's going to be equal to half of arc number 1, which is our larger angle, 140, minus arc number 2, which is the smaller angle, 66. Okay, follow your order of operations here and make it easy for yourself. Start inside the parentheses. 140 take away 66 leaves you with 74. And now we need to find half of 74, which just means we need to divide by 2. I come up with a 37-degree angle at KML. All right, let's give it another shot. In example 11, I've got a tangent line on the right and a secant line on the left. So we're looking at our second piece of notes here. We're trying to solve for angle ABC. All right, our formula or pattern goes that the angle is equal to half of the difference of the two arcs. We're solving for the angle. We're supposed to find our two intercepted arcs to plug into the picture, to the formula. One is very clear, 62 degrees. The other is unknown as it is, so I'm sure there's some other kind of work to do first. Okay, take a look at this circle. There's an 88 degree floating out here, 62 degree, and something else. We know that a full circle adds up to 360 degrees. So if I take off the two pieces for the other two minor arcs, what will be left is going to be this missing arc that I need to plug into the formula. So 360, take away 62 and take away 88, leave me with 210 out here on this large intercepted arc. The small intercepted arc is 62. So let's do order of operations. Start within the parentheses. 210 take away 62 leaves you with 148. And we need you to take half of 148, which is 74. All right, let's take a look at example 12. 12 has two tangents. So you're dealing with the example or the final piece of the notes here, two tangents. Okay, the angle is equal to half of the difference of the arcs. I know I keep saying it over and over again, but I'm hoping if you hear it and see it, it'll sink in a little bit better. All right, well, the two arcs are PR, which we don't know, but I'm sure we'll be able to find, and the major arc PSR, which has been given to us as 313. Okay, well, there's only two arcs on this circle, and we know one of them. There's 360 degrees in the full circle, and there's 313 of those degrees being used for the major arc. So if we subtract off that 313, that leaves us with 47 degrees for the minor arc. Now we have both arcs to plug into the problem. We're searching for angle PQR. Our large arc is 313 degrees. Our smaller arc is 47 degrees. And now we've completed the formula. Start inside the parentheses. 313 take away 47 leaves you with 266. And we're looking for half of that value, which is 133. I always like to go back and look at the picture again. This is an obtuse angle, so my 133 degrees makes sense. All right, we've got one more to go here. I want you to try number 13 on your own. Try to identify which picture you're looking at so that you can have something to go on. Okay, I've stopped my problem midway through to make sure that you are able to fill out the formula. So the pattern is the angle is equal to half of the arc minus the arc. In this picture, the intercepted arcs are BD and AE. AE is clearly marked as 67 degrees, and that's the larger arc. BD has not been clearly marked, so I wanted to stop here and make sure that you understand how to find that value. Well, check out our circle and check out where this secant line on the left cuts through. It cuts through right at the center, so it's a diameter. And if it's a diameter, it cuts the circle in half, which means you're only dealing with 180 degrees on the right side. So if there's 180 degrees on half the circle, we've used 94 here outside of the angle, and we've used 67 here on the intercepted arc. Whatever's left after subtraction is going to give us that teeny tiny slice at the top. 180, take away 94, take away 67, leaves me with 19. So this arc BD is 19 degrees. Finish out your problem now. I got a final answer of the angle is equal to 24 degrees. In our next video, we'll look at page 3.